great opportunity to hear from a great speaker. We've got David Bell today, Dr. David Bell. He's coming to us from Bell Rock Technology, from the Bell Rock Technology Project. He's going to talk to us a little bit about his own experiences in respect of the difficulties, problems, and improvement opportunities related to how you deploy data science, insight and analytics. And I know from talking to David at the start, and some of you will have heard that, what he's particularly keen to hear about your own experiences and to share some of those experiences and insight as to how you've overcome the challenges. I'm not going to say much more. I'm going to hand over to David, who's got some slides he will share with us. But what I'll try and do is pick up the Q&A feed from the chat window. So please, if you do have a question, either put it into the Q&A window or put it into the chat window, and we'll try and pick that up as a general theme a little bit later on. So without further ado, David, if you want to take control of the screen.
Perfect. Let me just share that. Can everyone see the screen? Can you see that screen, people?
Yeah.
Perfect. And thank you very much for the introduction. So hi everyone, again, thank you very much for coming here. I really appreciate it. I know these are, as Paul was saying, a bit strange times. And I also know for these meetups are normally sort of made a bit more appealing by the free beer and pizza that comes along with them. So 10 o'clock in the morning without any of that, the amount of you guys showing up is fantastic. So thank you very much. And yeah, so I'll start the talk. So I'm David Bell. I'm a product manager at Bell Rock Technology, which is a software company based in Glasgow that looks at overcoming a lot of the problems people have around data and analytics. I've kind of realised I've not really done much more of a bio than that, but to give you a quick introduction to myself, my background is I started off working with data in my PhD many, many years ago, I think like 15 years ago now, which was looking at applying data-driven approaches to mobile robots to model and adapt their behaviour. I ended up moving into a research position in an engineering department, looking at how to apply machine learning tools to large-scale industrial and engineering problems, before finally moving into the sort of commercial world and focusing on data science across multiple different industries, which is where I've been for the last 6 years. And to bring it back to the talk, the thing that we've saw again and again via academia or commercial and various other industries is deployment seems to be a massive challenge wherever I've been, trying to get these tools actually out there and used. So today's talk is just going to be about that, about some of the problems of deployment and how we can overcome them. So the quick agenda for this talk is just go quickly run through what deployment is, why it's a problem, what are some of the challenges, and finish up with outlining some potential solutions. So what is deployment? So when I'm talking about deployment here for the purpose of this talk, deployment to me is the productionization, full end-to-end productionization of data science models or machine learning tools. So that's kind of going from, taking a model from a data scientist hard drive, putting it into somewhere where it's accessible, typically the cloud, integrating it with a data source, and starting to produce results people can use. And to me, this is a key part of any data team. It's not necessarily the data scientist's job, but it is that responsibility to make sure this happens. Because as a data scientist, the thing that's always motivated me, I think it's always really got me excited about the role, is solving problems. And most people I talk to the same. It's that kind of overcoming these problems that's a really interesting part. And building a model doesn't typically solve a problem. It can be a great first step, and it's one of the key steps. But you can have the best model in the world, but if it's sitting in your hard drive not producing results, then it's not really valuable to anyone. It's not actually impacting anything. So that deployment becomes key. And deployment isn't just throwing it to an API and calling it done and walking on and changing, change the project and moving on with your life. Deployment is just having this data flowing in, the model's running, and information coming out the other end people can actually use. And at that point, that's when you're actually solving that challenge. So I guess the next question is, why is this a problem? And again, to me, the thing I saw again and again is the main reason deployment seems to be a problem is it's just not often thought of that often. It doesn't seem to be given the same sort of consideration as many other challenges around data science. So I'm going to show you a diagram here. You guys have no doubt saw a million times in different talks. It's the predictive analytics lifecycle, or the data science lifecycle, or whatever other lifecycle you want to call it. Just showing you the sort of path people take through a data project. I haven't been to a lot of conferences in my time, a lot of talks, and met a lot of data teams talking. The top half of this diagram, gets lots and lots of attention and investment and excitement, whereas the bottom half gets slightly more ignored. So when it comes to things like data, that's a massive, massive part of any data scientist's journey. So there's a whole lot of tooling around storing data and extracting data, putting data in motion, all these different ETL pipelines and data warehouses and data lakes and everything. That gets a lot of attention. So it's a well understood area. When it comes to analysis and cleansing of data, that's pretty much the bane of every data science life. So that's always hear the statistic that 70% of your projects spent cleaning data. So there's always a lot of talk about how can we improve that? How can we speed that up? How can we automate it? How can we get that sort of faster, better, easier? And then we come to the actual modelling part, the data science part. That's understandably the start of the show. That's the bit there's also all exciting around is new approaches, new techniques, new tools, libraries, automating machine learning. All of these things become get a lot of attention, a lot of investment, and a lot of press. And then we kind of get to the deployment and integration part, and it just seems to be skipped over a little. It's mentioned, but there's not as much, pizzazz around it. So it just kind of moves on. And then we get to the into operation again. All of a sudden, exciting comes back when it comes to how do you get this users engaged? How do you tell a data story? How do you build these business intelligence tools and all these other things to really hit this journey home? Well, that data deployment and integration is completely key to making all of this work. But there seems to be almost a kind of shared delusion between data scientists and management that, to use the old mantra, if you build it, they will come. If you create this amazing model that is just fantastic and cutting edge, all the kind of challenges around deployment and integration will just kind of melt away, and the fantasticness of your model will just push it forward with momentum. And that typically doesn't happen. It can be a real problem here. In chatting to quite a lot of teams, there seems to be this idea of how data science is deployed. It all starts with a management team or a board having came back from some conference and realised that data is the new oil, or data is the new electricity, or whatever else somebody's told them it's a buzzword that they love. And I think we need to get more value from this. We're sitting in a gold mine of data. So they go and they chat to one of their end users who's an expert, typically overworked and doing everything. So they're like, how can we use this data to help your job? How can we use this to help the company? And again, when it comes to offloading work to somebody else, there's no end of possibilities this person has. So he started to create all these data opportunities. What would make his life easier? What would make him more productive and effective? And they go off and they hire a data science team to come in and start to look at this data and these problems and understand how we can actually overcome some of them. So they'll spend time analysing this, building solutions, getting things ready, and start to deliver them back to this end user. And this will kind of go through a cycle. He'll give them more opportunities, the data science will deliver more solutions, a person's role will improve, the efficiency will improve, the company will start to improve, it'll grow and grow and grow until they become more and more data-driven, until they start to crush the competitors, become super profitable and become the next Google. And that seems to be the sort of thought process of how this will all work. But typically when you actually talk to teams who've done this, or when you actually look at teams who then start to do this, the reality is slightly different. The reality starts the same, and it goes all the way through to the data side the same, except when you actually go to deploy these models, what they tend to encounter is a series of challenges. I don't want to overstate this or make too bold a statement, but typically nearly every company's data is terrible. It's normally fairly badly stored, it's siloed off, it's in all different places, and it's hard to manage. And therefore integrating with it and getting access to that becomes a problem. And you end up needing this, fairly large team of people to make all this work. So you need developers and engineers and systems architects and data engineers, etc., all working together to then try and take these models and integrate them with the data and produce them to the end users. And if a company doesn't have access to those teams, or even just has the teams, but teams are busy doing various other things, then this can start to hit a real wall. This can start to be a real blocker and start to become a massive challenge. In actual fact, it's become a really big challenge. So looking at deployment, there was a talk last year by IBM, Support with Gap, that was looking into this. And their statistic was 87% of analytics never made it into production. And to me, that's a terrifying number. That's an insane number. 9 out of 10 data projects never actually get into production. They just get put on a shelf somewhere or don't fulfill the potential. Because again, until this project's into production, you're just not getting the value back from that investment. You're just not utilising all these data science teams effectively if they're just either stuck writing reports or producing nothing. However, Gartner was slightly more optimistic, so they also looked into this. And to them, they found 80% of analytical insights will not deliver business outcomes. And again, that's better, but not by much. But again, in the report they produced in this, the reason they stated for not delivering these business outcomes was due to lack of infrastructure. So that's again still a problem. And finally, and the most optimistic of the bunch, is New Vantage did a survey of various managers of data projects to see how they were actually working with all of this, and actually got a return of 77% said that business adoption of data and AI initiatives represent a challenge. And again, that was due to not having the ability to operationalise them. So these are just terrifying statistics to me. These are absolutely not the way it should be. And it's a point I'm quite passionate around, because this is data science and machine learning is such a powerful tool that seeing so many of them get blocked is just depressing. And I think the biggest thing that hits home for me is I've been one of these statistics. So I've been a part of these, and it's just so disheartening. My first ever data science project, many years back now, was one of these statistics. So me and a colleague got hired to analyse a significant amount of data to try and look at the major components, to predict the major components that would go fail across a fleet of assets. And we started a good task with that. So we spent a year working with this company to understand their data and understand their challenges and their assets and how we do it. And started to build these models. So we're kind of looking at how we could do these models, how we could predict these failures, which in turn would allow them to have better management of their inventory and lower maintenance time. So what went off, and we started to build the models, and it turned out quite successful. So they then came back to us and said, could we get a tool for this? Is this something you can deliver so that we can then use on a regular basis? So we're like, okay, no problem. So we kind of discussed with them what that tool would be and what the requirements were and all these sorts of things. And off we went and built it. And the product was a success. In fact, it was a massive success. We put this together, we had the models running, we had this gorgeous front end that everyone could use. The gorgeous front end might be a lie. Gorgeous is maybe a stretch. As two engineers with absolutely no UI UX experience, we probably used more checkboxes than any sane person should, but it worked. It was functional, and everyone was very happy with the result. And off they went, and we moved on to a different project, as you do. But 3 months later, we were kind of wondering why we'd never heard from that company again. We figured there must be a couple of bugs that would be worth fixing, or at the very least, a change request to make something blue. And we thought we should probably figure out why. So we'd given them this cloud database that we still had access to as admins. So we thought we'll have a peek at the logs and just see what's happening. And what we found was nothing. Actually nothing. There hadn't been a single record created, there hadn't been a single login, and there hadn't been any movement in this data at all. So we kind of phoned up one of the engineers we got quite friendly with and asked him just a bit what's happening? Why has there been absolutely no activity? And it turned out, they couldn't install it anywhere. IT wasn't comfortable letting them install an executable from 2 random people. So that got blocked. So they tried to install it in a random laptop they could use, but they couldn't punch through their own firewall to access the databases, and they were having trouble getting the data into it. So in the end, it just got shelved. And that was just crazy to me. This company paid hundreds of thousands of pounds for this product. Not to us, we were junior data science, we saw none of that, but in theory, they paid hundreds of thousands of pounds for this product, and it just got put on a shelf somewhere. And yeah, I just found it really demotivating. And I'd love to say that's the one and only time that happened. But what's worse is we've started taking these statistics around to people at the moment. When we've been talking at conferences or talking to data teams, and we quote them that 87% of analytics don't make it into production. I think the worst thing we find is that most people just agree. Most people don't find that shocking. Oh yeah, that makes sense. That's my experience. In fact, we took this to a very large data science team, a very big company, And when we quoted on that 87%, the response was, "Huh, that seems optimistic. I thought it'd been higher." And it just seemed to be accepted. And this is typically the point where, if we're in person, I kind of throw this over. And again, if we can even do any of this in the chat, that would be fantastic. But just curious, is that the kind of thing that you guys have found? Like, does that statistic resonate with you guys? Is this a challenge, or is this something most of you have actually found not too bad, or stall? And again, just something curious, because it's. I'm just seeing if I can actually see the chat here, but.
There's nothing come up at the moment. I mean, my experience is that those figures do not look unusual with my knowledge of projects that take place within large corporates. I think one of the things that I find quite interesting, though, is there's a degree of overlap in there. And if you look at some of the early web-enabled projects in the late 90s and early 2000s, they had similar levels of failure. And a lot of the analysis that was done mid-2000s to try and look at that was trying to understand the extent to which it was a project structure that had led to that, or whether it was a lack of project governance, whether it was a problem related to not commissioning something which was a well-defined business problem. It's that classic thing of something's broken, or we fix something, something's loose, we've tightened something. Actually, you need to sit down and work out the granularity of what it is you're trying to deal with. And in my experience, those stats largely stay the same all the time. You're avoiding doing that. So we've got some people coming up here now that talk about AI, UI users and developers working together with the data scientists. I get that that's not straightforward, but again, I think it's a start, because you start to bring those different people from different parts of the business together with the domain expertise, and the prospects are you'll at least tip the balance ever so slightly. But there must be other things you can do. Have you found anything that is actually fundamentally shifting that figure for you, David?
Yeah, definitely. So that's actually what the next part is kind of looking at some of this. And actually, your responses have been fantastic. Actually, that kind of resonates with exactly what we found. Is a lot of it is to do with the project management of these and understanding effectively the full end-to-end process and where you're going there.
Just seems a bit like, data science becomes the latest victim of poor project governance. You get transformation projects and programs that fail because of poor governance. You get IT projects that fail because of poor governance. And unfortunately, it's the easy out to be able to point a finger and say, well, maybe we should never have got into this in the first place. Whereas in reality, it's a more endemic and underlying issue of getting the governance right and getting the tone at the top right around these things.
I completely agree.
I'm going to leave on with that.
No, in fact, actually, what Paul's saying is absolutely fantastic and absolutely true. Because one of the things when I started this, when I was looking into these statistics and been looking into the sort of deployment as a whole, one of the things I found really interesting was that question: is why is this a challenge? In fact, what Paul's saying exactly. The reason is, why is the challenge? In the sense of, we've deployed software for 50 odd years, and at the end of the day, data science is effectively just software. So why has that become such a problem? And I actually think governance is one of the key issues of that. There's a whole lot of technical challenges, and there's some interesting cultural challenges that actually pop up. And some of them are just things like data scientists tend not to come from development backgrounds. Some do, but many come from things like physics or maths or statistics, and therefore don't necessarily have the experience of deployment or developing software. There's also the interesting point of a lot of teams, when you bring in data scientists, and this was mentioned in the chat of what they're trying to do, but a lot of data scientists are quite siloed off. So you have these cross-functional product teams of developers and DevOps and systems architects and designers all working together, and then you have data scientists on their own as a group, working problems on their own for a company or department. So they're not getting that knowledge here.
Yeah, it's interesting. One of the questions that's been posted into the Q&A feed very, very much asks that, or poses that challenge of, should it be left to the data scientist or the analyst to actually deal with deployment? And I think the answer you've just given, which is essentially that not unilaterally, is the answer. Having that blended team of flat process team is probably going to give you better results.
Yeah, very much. I think data scientists should be driving deployment, but yeah, I don't necessarily think it's their responsibility, because you do need all that support around it. But one of the things we're actually going to jump onto now as one of the main challenges I've saw again and again, actually, again, really relates to Paul's point of governance. One of the big things is actually, the key thing that's a failing for nearly every data science we've saw that doesn't go anywhere is understanding where your live data is coming from. And I think this is one of the most important things, is just knowing at the start of how you're going to get that live data. Because getting batches of data is actually remarkably easy. It turns out asking for the last 5 years of a database is quite a simple task, and everyone's quite happy to give you that, and you can go off and train them on. But actually integrating with databases or APIs or actual tools, assets itself, that becomes really difficult. And it is something that we see again and again. And kind of the main reason for that is back to the comment earlier is, joking aside, is that data in companies is generally quite badly managed. It's getting a lot better, but it's so often kept in all these different siloed databases. They're all using different formats, and connecting, integrating, and bringing that all together in one way becomes really difficult. It also means you actually have to start negotiating with a lot of different teams to access that data. And again, IT teams are generally great, but they're working full pelt on keeping everything up and running. And when somebody comes to the end of the project who they've never spoken to before and don't know what they're working on, start asking them to drop everything and start creating APIs and database access, that generally gets put to the bottom of their to-do list. Or alternatively, you actually have quite often teams that are managing data structures that are not the most robust. So you have these databases and data systems that are held together by kind of duct tape. And when somebody comes and asks for an API that can pull data out like 1,000 times a minute or even more, then that's just not necessarily possible. And finally, and this is rare, but occasionally you just end up with kind of a crazy person who's managing the data, who thinks that data is the source of all their power, and opening that up to somebody will diminish that. That's not common, but you'd be surprised. But getting access to this data is just such a core part. And again, I think this is back to what we just mentioned there in the sort of chat is, the core takeaway from this talk for me, the core sort of message I think is just really, really important is understand where your live data, your production data for is coming at the start of the project. Like, don't assume that once you've done everything that this will just all melt away and you'll get your product in there. It's like you need to know right at the start where your data is coming from, how you're going to integrate it, and who's responsible for that. And in fact, having a data sponsor, and again, to go back to that other question, it's not necessarily the data scientist's job to do all this, but having somebody who at the start of the project is your job, who's going to make that available to you, is such a key part of making this work. Because if you get to the end of your project and you've not actually thought about how to actually deploy this, you're kind of hurtling towards one of those statistics we looked at. And I think actually the broader point here, thinking of it, is not even just know your access to data at the start, but know your route to deployment. Know the entire route to deployment of where you put in that model, how you go integrate, how that data will flow when you begin a project, not at the end. I think that's really key. And I know it's not exactly the most insightful comment. Like that's not it's fairly common sense, but again, it's overlooked because people get caught up in the modeling part that they don't think about the deployment. So that's my big sort of push or takeaway, is just understand your path to deployment before you start a project.
I think it's an interesting point. One of the comments that was made in the chat feed is that you won't always know about deployment, or you won't always be involved in deployment. If you're working maybe for a vendor where the project is to essentially develop out a product or productize some piece of data science, and the deployment is going to be left largely to somebody else, maybe another team in your own organization or maybe an end user organization, that can become a real challenge because they might put their own spin on how that deployment takes place.
Oh, very much. But again, I think that's why you need to bring whoever it is in at the start of that project. So identify who is going to be in charge of that deployment. And you don't have to be heavily involved. Like they don't need to be running or really feeding into the project, but just having that understanding so that they, where that model is going at the end of this, and they know how they're going to take it and run with it.
To what extent are you finding that there maybe is a, I don't know, it's almost people, client side in particular, but people abdicating their management responsibility for the deployment. So I've thrown the problem to you. I expect you to solve it with a whizzy piece of data science, and I'm expecting a decent UI in there as well, just for good measure. Now, when it doesn't give me the answer I want, I can just point a finger and say, well, it was all your fault. But actually, all I've done is pass the management responsibility to someone who really probably shouldn't be shouldering it.
So actually, I think that's kind of one of the next things they're talking about. Is that kind of the economy of that? Or do you just give it to the data scientist and say this is your responsibility and your responsibility alone? Which you end up with the data scientist working things that not necessarily should be? Or do you hand it off to somebody else? And again, it's the opposite problem. The data scientist washes their hands and walks away, and all of a sudden somebody else is left holding a model on how to deal with it.
Yeah, interesting point. Interesting point. I'll hand it back over to you and mute.
But no, actually, that's genuinely this part is, again, understanding that path to deployment and trying to make that as pain-free as possible. And one of the problems we see again and again is actually what we just talked about there, is there seems to be two very common approaches to deployment that both have issues. And the first is this, most traditional way of deploying analytics, which is the data scientist goes and develops his model on his own, and he then kind of throws it over a wall to develop, who takes that, recodes it into a different language, and integrates it with the system. And this is kind of an understandable way of doing things, and especially if you're doing a mission-critical system where latency is the key, then changing from a scripting language to a compiled language makes sense. But for most other people, it really doesn't, because it just slows everything down. The data scientist gets to wash their hands of it almost immediately, and then you have a developer who has to take this data science model and translate it into a entirely different language, which means you end up having massive differences between your production and your development environments, which is kind of a surefire way to lead to bugs or drop accuracy. It's also quite a slow process, just simply because you have this kind of sequential chain of, data science does their job, there's a brief period of crossover between the data scientist and the developer to communicate, and then give it to the developer to do their bit of the work. And by which point you've done, the data scientist typically updated the model at some point, you have to kind of go around that circle again. So it's just not the most efficient process. The other end of this is actually, again, what we just mentioned there, is there tends to be a lot of newer companies kind of put the responsibility on the data scientists for all of this. So, they have to build a deployment platform, clean the data, organize the pipelines of that data, make a robust system, make a front end, have that hosted somewhere. And that's not necessarily the data scientist's responsibility. Data scientists aren't developers, so they can definitely do some of this, and there's some fantastic systems built by data scientists, but it tends not to be as robust and reliable as a system built by a developer. And as an aside, it tends to make a lot of data scientists quite unhappy. So data science is voted constantly one of the most desirable jobs, but it has a massive turnover. And again, a lot of studies have shown that that's because data scientists get brought in to do non-data science things. So if you show up and start building machine learning models and you end up being a systems developer, then you feel that you're not actually doing what you want. Start to leave. Whereas to me, the key here, when you see the successful solutions for this, it's kind of bringing the two together. Because you do want a development team making a deployment system. You want some way of getting these models repeatedly and reliably into production. But that shouldn't be developed by the data science. The data scientists should be stakeholders in this process, but you want proper development teams working on it. But building those systems becomes difficult. Building those systems themselves get really hard, and there's a whole manner of challenges to making that work. And one of the first ones is the kind of dependency hell that comes from data science tools. So, your typical data science will use a variety of languages and libraries. You've got Python R, you've got libraries like NumPy, SciPy, scikit-learn, and Pandas. You all use in a project. And then all these libraries nobody's ever heard of. But more importantly, there's multiple different versions of them. You might be using different versions of Python, different versions of libraries, so that updating a model, from 6 months ago, you could end up having completely different dependencies than that 6-month-old model. So if you go to actually run that old model, then all of a sudden, nothing's giving you the same results. If you don't keep on top of those dependencies, you try and run the old model with the new libraries, and you get different outputs. Keeping track of all this can be quite a chore. Again, it can take an engineer a day just to try and untangle all these dependencies and versioning just to put it into production. It also leaves a big problem with kind of data auditing, because if you do go back a year and try and run something, you might not be able to. And depending how core data auditing is to your process, that can be devastating. So kind of the solution here is looking at containerization. This is a really good way of handling this. And for those who don't know about containers, it's effectively creating a small custom environment that you can put all your dependencies and libraries and set up effectively. You can configure that all in this little environment, put your analytic in, make it run, and then it makes a very transferable environment. So you can then push that off from system to system. It will always run the exact same way. So you can pass it off from your desktop to a cloud to a production environment, and you can guarantee that it's going to have the same execution environment. And Docker is the most famous one of these. Also, as an aside, it makes things very portable, which is nice. As much of your system as possible should probably be containerized at this point, just because of that portability. One of the things we saw again, which can be problematic, is kind of legacy analytic systems that are very, very coupled to their technology, which means when it comes to moving from on-prem to in the cloud, or try to take advantage of the latest things like GPUs, then it becomes a massive work effort to port that over, as opposed to just something simple. The next thing to just talk about quickly is the sort of problem of pipeline jungles, and this is kind of a famous machine learning one. As you start to deploy more and more analytics, and again, you should be working towards a system that allows you to start deploying tens to hundreds to thousands of analytics as a whole. The pipelines that get created to manage this can become massively complex and difficult to stay on top of. If standard analytic might need a module that brings together data from 2 or 3 different databases, that will then flow into another module that starts to cleanse that data and make it sort of fit for analysis. That can then flow into a feature extraction model. It can flow into an actual analysis model that can then flow into 6 or 7 downstream models that all are doing work independently. And there's a great quote in machine learning that I've came across a few times that I really quite like, which is changing anything changes everything. So the problem with these sort of pipelines is if the data scientist updates their model, take in some new feature that they think helps improve their accuracy, if you're managing all these pipelines manually, then you can have this problem where now you need to change your data combination to bring in additional data. You need to update your feature extraction algorithm. You need to update your data cleansing algorithm. You need to update your model. And any changes to that model may impact all these downstream models that now need to be sort of kept on top of. So it becomes really problematic and time consuming. So you really want to try and make sure this system's modular. And it makes it easy for data scientists or developers to pull out different parts and push in others, and just really quickly experiment and scale. Because part of the goal of this deployment system is not only to speed up data scientists, but to not slow down your development team. The other thing you kind of need to be aware of with these systems is making sure they're scalable. And I guess this is kind of a key one. So data science models can consume a lot of resources. The one thing I'd actually say is most don't, oddly enough. There's a big misconception that most data science models take up massive resources. Training models can be quite resource intensive, but actually using the resulting model for inference is generally pretty light. But if you start to dip your toe into things like deep learning, then all of a sudden those resources can start to go through the roof. And you can have the issue of peak periods. So if your model service that you created or your app you created gets used heavily between, say, just 4 and 5 p.m., you need to then make a call of, do you scale that up for the full day, just for this 1 hour, which costs a lot of money? Do you leave it low, where you end up starting to bottleneck people's use at that sort of peak period? Or do you employ some poor engineer to crank up and down as needed every day at that period? So again, to try and make this sort of easy and useful for people, you kind of want to make sure you have this kind of elastic deployment, something that allows you to scale these up and down automatically, and make this easy for people. And again, there's a whole raft of technology of doing this, from serverless functions to orchestration platforms. But that all needs to be monitored as well. Actually, the last sort of note on that is, I think lots of people have heard the stories online of the person putting a model into deployment and consuming their entire month's Amazon budget in one go. So that you kind of want to monitor those. But you also kind of want to monitor your models. So one of the other problems of putting a model into production is it doesn't end there. So putting a model into production to actually run, that's again a massive stage, and you're starting to get value from it. But you still need to keep on top of that, because the data feeding into the model can start to change over time, in which case your models start to produce bad results. Or models can start to become less accurate. So again, model drift is a massive problem, where if you're modeling an underlying environment or underlying system, and that system starts to change, then all of a sudden your model can become out of date. And this is something you really need to keep on top of. Because again, the goal of data science is to solve problems. And if you're starting to produce bad results to people, then all of a sudden you can actually be creating worse decisions rather than better. So this is key. And there's a whole raft of tools that can do this. There are some really fantastic tools for using statistical analysis of inputs and outputs to try and detect as they're changing over time. So that's really it for the challenges. I just kind of want to conclude in a quick section of what some of these solutions could look like, how you'd pull this all together. And I'd love to say that this is a nice, simple pull it all together and this will work for everyone, but the reality is there's so much variance in people's own problems and demands that there's not really a one-size-fits-all.
Just on that, David, just before you move on, I mean, it's really interesting about the model drift, and it is something that I've experienced and seen quite a lot of myself. And if I could just borrow the term and maybe bastardize it ever so slightly, what about client drift? What about when your clients change or your end users suddenly decide that the model isn't fit for purpose because there's some gem they haven't shared with you during the initial consultation with you?
So I actually think that's a massively important point, and I think that's back to this, you kind of want these modular systems. So to me, like, the worst thing you can do in a data science project is go off for 9 months building a model and then coming back at the end with a sort of, ta-da, this is done. Actually, if you've got a system where you can start to put things in front of the user quickly, and not when they're bad to the point of going to cause errors, but if you can start to iterate very quickly and be delivering value at each stage and getting that feedback, then you can try and course correct as you go along and kind of make sure you're actually solving the problems they have as opposed to what you think they have.
Yeah, I think again, good point. But I know that the general view is that you'll have people that self-select or are conditioned to be either classic internal validators who want that ta-da moment. They don't want anything to do with it until you're ready to do the classic reveal and move the silk cloth off it. And if it's not right at that stage, then you took the brief wrong. And then you get the other side of the equation, which is the classic external validator of, well, actually, I want to know on a weekly basis what the model looks like, and I want you to show me the build as we go. And clearly, your own model of operation, your own MO, may actually be in conflict with either of those two models.
Yeah, very much. And I guess that's something that at the start of the project is something you need to suss out, because if you can even bring in some of the external validators at the start until you can build up to the internal one, then that can help along the way. So even if you have this small group of people that are interested in seeing this and steering it, so you can build towards that final bang with the rest of the group. That can at least mitigate some of it. You still have the age-old issue of eventually somebody going to still be unhappy because the group didn't speak for them personally, but at least it helps you sort of course correct a bit more towards that.
Okay.
But I just kind of wanted to finish up outlining a few different potential solutions to this. And the first one is a kind of standard approach that I think will work for quite a lot of people on a small scale. So if you're just starting out, this is quite a nice way of doing it. And that is just you build your model offline using your language of choice. Yeah, and for this example, we use Python because it's the one I'm most familiar with. So you happily go and build your model in Python. You then serialize that model. So serializing a model basically takes your kind of complex Python object and stores it in your hard drive as a nice simple file that you can then pass around and push to a production environment. And there's tools like Pickle for Python, which allows you to do that via a Python library, just in code, nice and simple. You can then take that model and wrap it up as a sort of something that drives it and push it to a RESTful endpoint. And again, in Python, there's a nice tool called Flask that allows you to take your model, take in data via a HTTP request, and push out results that you can then take and store in a database. And this is kind of a good way of getting started. Like, I know in these talks, generally, we have quite a lot of students come. So if you're a student viewing this, and this is kind of a great way of just deploying a model, or if you're a small company just starting out or just wanting to play around with data science, this is a great way of just getting something up and running where you can push data to it, you can get results back, and then from that database, you can build out an app. And that's kind of a good starting point. If your actual business is wanting to move forward this into an actual more production scale, something that actually be useful, you can then start to look at containerized analytics. So again, using something like Docker. And by this I actually mean containerized full Flask element, actually, the full HTTP production part. can be containerized, so you can fill out your environment with all your dependencies, all your requirements. The data science can build that in the laptop, and then you can push that off to production. And that gives you a kind of repeatable way of pushing analytics into a system. You can then look at things like extract, transform, and load systems to actually integrate with your multiple different siloed data sources, combine that, clean that, and pass it into your analytics. And there's a whole raft of tools for ETL that are some really good open source or paid ones. But things like Apache Nifi or Kafka or Airflow are all pretty good ones to look into for this. But this gives you a kind of repeatable way of pushing these analytics in. And the one thing I'd say here is this looks like 2 simple bullet points, but at this point you're going to need quite a lot of development team to actually make all this work. So there's quite a lot of glue code involved in organising these systems. There's actually a fantastic paper by Google called Machine Learning, the High Interest Rate of Credit Card Debt, or technical debt, sorry. It kind of says that most machine learning systems are 95% glue code to 5% machine learning. So you might need a good team of developers to make this work, but it does give you a repeatable system where data scientists can push their analytic in and data will start to flow through them, and that's kind of key. If you go to sort of enterprise level, if you then want to build a full-scale industrial system or a full data product you can take out to people, then you can start to look into things like container orchestration. So Kubernetes or Amazon's ECL are the kind of key technologies here that seem to be used. And this allows you to add a level of robustness and fault tolerance to your system, and allow it to start to provide that scalability so that it can ramp up demand as and when needed. And this is a fantastic way of doing this. The only catch here is this is when you really do need a good, robust development team. And if I can mention, a DevOps team are worth their weight in gold at this point to make all this flow. But it does give you a kind of enterprise-ready product. So those are just kind of an outline of different approaches you can use, and how you can sort of start to build that yourself and build that out. And again, you can start at the sort of initial part and build up to this as you go. But again, it does require a significant investment in time and money. If you are wanting to jump ahead a little, you can look at some of the products available and how that can get started now. And what I would say is, going back to that very first slide, the data science cycle, again, there really isn't as much buzz or excitement or investment in deployment as some of the other approaches. So you do get some really nice model building tools that do let you do a one-click deploy, but that tends to just be pushing out an API, and then you have to do the rest yourself. And the various cloud providers all also have their own solutions for deployment, and some of those are actually really quite good. But they do involve buying into that cloud full scale, and they can be quite inflexible as to how you work with them. Also, you probably need a technical team to sell. Like we worked with a company who went full buy into a cloud provider, and without a technical team, we got quoted that it would take 6 cloud engineers to make one analytic work. So you still want a good team behind that. But the last thing I just want to mention is a quick plug of our own, actually, is we've developed a product, Lumen, which is designed to take as much of the pain out of data science as possible, or deploying data science as possible. And this is the kind of thing that we've been working on. And Lumen's an intelligent platform that allows us to connect to multiple different data sources, pretty much any type, from databases, APIs, cloud sources, file stores, etc. Pull that into the system, and then allow data scientists to deploy their analytics in pretty much any language they use. So we can work with Python, R, C++, Java, etc. And when you push the analytic into the system, it gets automatically containerized, and then the intelligence of the platform allows it to automatically integrate with the data it needs to run. So for people who care about this sort of thing or interested in this sort of thing, Lumen's built in what's called multi-agent systems, which is a principle from AI that focuses on basically automatic configuration or self-organization. So when you drop your model into Lumen, it goes off and finds all the data it needs to execute, brings it together, and starts producing results. And that allows you to very quickly drop things in and see how they work and pull them back out. And it allows you to create these pipelines automatically. So you can drop in a couple of different things, they can all chain up, you can see how that's working, and then you can pull things out as you want. And I guess one of the things as well is use deploying analytics as our main use case for Lumen. But realistically, it's building data-driven systems. This allows you to take the rules that you use to cleanse data and operationalize it. And then the tools you use to extract features and drop that in there and have them start connecting and working. And dropping in analytic and more analytics and 6 or 7 analytics, and then pulling them together with an ensemble component, or pulling them together as a scoring component, and pushing all that through, and getting all these results. And then the results that are generated can be taken and pushed out to a variety of tools. So you can then push that out to business intelligence tools, databases, your own systems, however you want that to run. And start to get the value from those analytics. And it kind of allows us to do these deployments in minutes as opposed to months. So it's a really powerful tool. It also handles a lot of the more mundane stuff we've not actually spoke about today, the sort of less interesting side of things like security. So, everything's encrypted end to end. We have user access rights, permissions, login systems, authentication, notifications, so to alert people the minute analytics start going off or reaching thresholds, and things like the data provenance and audit trails of how that all runs. So this has been a product we've been working on for the last 7-8 years. So it's quite a mature product, and it's been in use at a variety of companies across the UK. Currently, 2 of the major ones are its use at SSE, kind of monitoring our deployment, their distribution network, and EDF for a variety of reasons. But one of the really interesting ones is currently Lumen is the platform for deploying innovation and research for monitoring nuclear power plants across the UK, which is one of the coolest projects I've been a part of. If I'm being honest, it's been absolutely fascinating to see. So it's been a sort of battle-tested tool, and we're kind of heading towards a product launch of the latest version next month. But I kind of just wanted to throw that in there. I don't want to turn this into a marketing spoon, but I just wanted to say thank you very much for listening. I hope that's been useful and you saw a variety of ways of how you can sort of tackle deployment. Get about for any questions, or otherwise, if anyone wants to email me, just drop me a line at david.bell@bellrock.tech. Thank you very much.
Thank you for that, David. Maybe just 1 or 2 questions on Lumen. I'm guessing at the moment your majority of your work has that been done remotely on Lumen, or have you done that on client sites?
Actually, it's all been a mix. So we've been on clients helping them get everything up and running. Obviously not just now, but previously we could help if they needed that extra help. We could go on site with them and help integrate their data and deploy their analytics and work with them. Or one of the things we've been building out is these tools to allow them to do all that themselves. So allow that remote working capability so people can actually push in their analytics from wherever they are, have them all join up, operationalize, and actually let them do everything they need to.
The concept of containerizing the analytics, I quite like the idea that is something which is almost sandboxing the environment to protect you from issues relating to data quality or the veracity of the data, or maybe even some of the security challenges you might get around access to analytics. Is it something which is stress tested to the extent that you can then deploy that operationally at scale using something like Lumen, or would you only use that during that early development stage?
No, actually, I mean, I think it's something that can be deployed at scale quite comfortably. So in this case, we actually do the containerization automatically. Right. So rather than let the data scientists do it. So they just need to work in their scripts, push that into the platform, and we'll build a container. And the reason for that actually was to avoid random containers being pushed in. It can have dependencies or malicious code within it. So actually the containers are all built, are all tested on our end. So you can put in your dependency, so it's not negating the power of containers, because you can just give a list of all the libraries and structures and files that you need, and it will create that container for you. But it also means that the containers are secure and well tested themselves, and can then be scaled out as needed.
Right. So, as you said earlier, we often, on the meetups, we often get a regular cadre of students who will come along to events like this. If you were talking back to your student self, and I'll let you pick anywhere on your journey to the PhD in terms of where you might advise yourself, but what advice would you offer around trying to acquire other skills that you found quite important to actually ease the burden of deployment, knowing what you now know?
Well, that's a good one. Again, it would go back to the first point of make sure you ask those questions at the start. I think definitely me and very many data scientists get so hung up in the modelling part, because that is the interest, that is the exciting bit. That understanding what other people are doing. It would also be that if you're doing it in a commercial capacity, or any capacity actually, to be honest, even in research I could have learned from this, is try and get as many of the key people in a room at the start. I honestly think actually getting IT teams in, one of my biggest problems when I was starting out, I think, was I used to view the IT teams as almost an enemy because they'd be the ones blocking everything. And having got to understand their role better and what they're doing, it is really down to this aspect of they're trying to keep everything running, and they're never brought in at the start, so they don't see your products coming until it's too late. In which case, all the focus goes on them as the blockers, which makes them the bad guys, and that oddly enough drops their willingness to help out. Whereas bringing those people in at the start, also actually learning some DevOps would be great. It was like a concept I never even heard of when I was still in academia until I started working with commercial teams, and just understanding some stuff around how to get servers and cloud servers working and running and containerizing is a great sort of skill set for data scientists to pick up. Again, not something you necessarily need to be experts in doing, but having that understanding of how to use those technologies or keeping track of where they're going is probably worth their weight in gold.
Yeah, there's no shortage of access to material for that either. I mean, the MOOC community has a tremendous number of freely available courses, short courses that you can run at a self-learning pace or a self-set pace. And I often participate in these myself, so I'm always surprised at how few people from the community are in there. It's normally people coming from the business domain experience side, coming in to learn more about what they need to know in order to be able to work effectively with data scientists and DevOps. And I wonder whether there's actually almost, it's a degree of we either don't know that exists or we know it exists, but actually it's not for us because it's not going to be at the right level.
Yeah, I really agree. And I think, again, a lot of data scientists are quite happy to just pass everything over. And just having that capability to dig in and actually help out or at least understand what the challenges are, I think probably really helps out there.
Yeah, I think James has just posted a comment in the chat feed about what are the links to these. If he's referring to the MOOCs, I don't know whether you're referring to the MOOCs, but actually if you go to either edX Learn or, if you go to edX Learn or you go to Coursera or FutureLearn, you'll find that a simple search in there, you'll have no shortage of content. There are a tremendous number of these modules that are taught by some of the world's best universities. And essentially they're provisioning their content that they've used for real world classes in an online learning format. And because you can cut and dice it around your own agenda, your own schedule, you can find very quickly, you can build up quite a strong and robust level of knowledge. Udacity, Udemy. The only thing I would say about some of these Udemy is an interesting one, but the charge models for some of these are quite expensive. edX is one of my preferred because you can study a lot of the edX ones for free, and if you want a certificate at the end, you can do the verification process and pay for that. Coursera is the same. Docker's particularly good. Never pay full price for them. If you hang around in a website, there's a website called Hot UK Deals, HuckD, and you can get the app for Google and Apple phones. And if you hang around in there, you'll find most of these courses are discounted down to pennies on a regular basis. So it's definitely worth hanging around in some of those areas. Even if you're just looking to pick up new programming language skills or DevOps skills or a bit more domain expertise, they're good places to go. And I think for the most part, they're quite complementary to other taught degree courses because they follow the same approach. They follow the same sort of academic robustness. I find them useful. Not everybody does. Not everybody likes them. A lot of people struggle with the fact that there's not somebody there with a size 11 leather enema driving you through that training material on a regular basis. You have to be a little bit self-disciplined, I think, to work your way through it. Any other advice for us, David, in the closing minutes of what's been a very informative presentation?
No, I think that's really it, to be honest. I think figuring out how you want to deploy, making sure you have that path there, make sure you have access to data, and having a think of the company of how you want to create that system and make that as easy as possible for people to get these models into production. Because again, it's such a valuable part. Data science has got so many amazing applications, but you really just want that to be working and actually producing results, and having a system that makes that as easy as possible for people to do that I think is massively key.
Just one final question I've spotted in the Q&A feed at the bottom there, asking the question of whether there's a different approach or different challenges that you've experienced to dealing with batch versus real-time predictions, and how you might handle some of those things differently from a deployment perspective.
Yeah, so that is very different, I guess. So most of the time we've looked at is more real-time systems. So with the batch analysis, it can actually be easier at times, simply because you're not needing a system to be constantly running. You can have it set up so you have a database of data that fills up during the day or however many months you want to run it. And then you can actually just do some quite simple, even cron job scripts to kind of take that batch data, run it through a model where it can take days or weeks or however long it needs to actually process, and then kind of output that back into another database. So it can take away quite a lot of the complexity, just simply because you don't have that rapid read or analysis a lot of the time. Understanding at the start of which process you do want to have, or having something that can do both, actually. I mean, having a system that can flexibly handle pulling a batch of data at a time and passing that through, versus being able to flow data in real time through it is probably ideal, so you can cover both cases. But otherwise, yeah, generally, this might just be my lack of experience with batch, but generally it seems a bit easier to stay on top of, just because you don't have that real-time need for somebody to get results immediately, and if something goes wrong,
it takes the urgency away.
Yeah, very much. It seems to be easier to set up just from databases and scripts as opposed to full-on systems.
Thanks for that. Well, thank you very much for your presentation today. I know you've managed to put your email address up there on that end slide for people to see, so I suspect you're quite happy for people to contact you directly if they have anything they want to follow up with, or maybe
very much.
The slides. I suspect you'll get a few people asking you a bit more about Lumen.
That'd be great. Happy to answer any questions.
Thanks very much, Paul and David. That was great. We've also recorded the session, so I can speak to David and yourself to see if we can distribute it to people who've listened as well. So thanks very much. Another great event. Thanks for everybody. I think there was over 80 people tuned in at one point. Not bad for a 10 o'clock on a Wednesday morning. So thanks very much.
Yeah, thank you very much for coming.
Thank you, David.